Hello students, good evening all of you. So here I am discussing one previous question. It is a last year JEE main question. It is placed in a January session, actually 2020 January JEE main question. Okay. So this question based on the Friedal acylation and the alkylation. The question is, which of the following compound produce a good yield in Friedal acylation reaction? Okay. So here generally it is based on the limitations of the Friedal alkylation and acylation reaction. Okay. So here in this case, you know that very well. This aniline is not involved in a Friedal acylation and alkylation reaction. This nitrobenzene is also not involved in a Friedal alkylation and acylation. Because here the compounds having electron withdrawing group are not involved in a Friedal acylation or as well as Friedal alkylation reaction. Okay. Why? Because here that in Friedal alkylation reaction, that alkyl carbocation is the reaction intermediate, that means alkophile, and in acylation that C double bond O plus is an alkophile. These alkophiles are stabilized by the here in this case it is stabilized by the resonance, here it is stabilized by the hyperconjugation. Generally here carbocations are somewhat stable, and this cation is also stabilized by the resonance actually. C double bond O here plus. That means here these alkophiles are the less reactive alkophiles. So here to react with less reactive alkophiles, here more reactive, highly activated benzene ring is required. It means this nitrobenzene is not involved in a Feldkopf alkylation or acylation reaction. Okay, because NO is an electron withdrawing group. That's why nitrobenzene is used as a solvent in a Feldkopf alkylation and acylation reaction. Okay, and next, okay, so generally here not only that nitrobenzene, okay, not only nitrobenzene, the benzene containing electron withdrawing group like CHO aldehyde group and benzoic acid benzaldehyde or any ester group or any acid halide group, okay, COCl or SO3H or CN, all these, okay, the benzene containing electron withdrawing group is not involved in a Friedal acylation reaction or alkylation reaction. If benzene contains CF3, CCl3, CN, SO3H, COCl, COR, COOH, CHO, all these do not involve in a Friedal acylation and alkylation reaction like nitrobenzene. Okay, that's it. Any deactivating group present on the benzene ring, it is not involved in a Friedal alkylation and acylation reaction. Now it is the aniline. Here actually that NH is the highly activating group. So it must be involved in a Friedal alkylation and acylation reaction. Now here this one in Friedal alkylation or acylation reaction, generally this reaction is taking place in presence of the Lewis acid. Hence here there is a Lewis acid. So here there is a lone pair of electrons. So it is electron donor, here electron acceptor. So that gives a Lewis acid base complex. That means here H, here H, this one carries a positive charge, and here AlCl3, this is a negative charge. That means here this nitrogen becomes a positively charged nitrogen. So this positively charged nitrogen is a very strong minus I group. So it is also not involved in a field of alkylation and acylation. Okay, because that donating group becomes the electron withdrawing group, very strong electron withdrawing group, positively charged nitrogen. Okay, and also here we can say that NCH3 thrice plus, it is also withdrawing group, very strong withdrawing group, deactivate the benzene thing. Okay, so benzene containing this group also not involved in a Feldkopf acylation as well as alkylation reaction. Now here coming to this phenol. Okay, actually here it can be involved in a acylation reaction. The phenol can be involved in a acylation reaction because here that oxygen is less basic. Okay, here nitrogen is a good base. That means it is a good electron donor. Here oxygen is a very weak electron donor. So that's why here in this case we can see the products. Okay, that means here acylation taking place for the phenol. But here in this case also there is a very less yield is produced. Why? Because even though here this oxygen is a more alkylative, that OH also slightly form a Lewis acid base complex with AlCl3, but not that much of aniline, because your NH2, the nitrogen is a more basic, is a good electron donor. It readily combines with the AlCl3 Lewis acid. Okay, but here this Lewis acid cannot be combined readily with OH as in the case of the NH2. That's why here we can see just there is a positive reaction for the phenol. Okay, so but here that produces a very less yield, because there is just some amount of the phenol also combines with AlCl3. That's why here in this case also very less yield produced. Okay, but here in this case chlorobenzene, it is successfully involved in a Friedal alkylation and acylation reaction. That chlorine is a very weakly deactivating group. Okay, so here we can get the more yield of the acylated product, that means C double bond O R, and here ortho isomer also. Okay, we get the very good yield of the chlorobenzene. When compared to phenol, here in this case we will get the good yield of acylated product. Okay, that's it. Now here from the NCERT textbook, here this anisole can be involved in a Friedal acylation reaction, and any halobenzene also involved in a Friedal acylation reaction. Of course, you know this one. Toluene can be involved in a Friedal acylation reaction. Not only toluene, any alkyl benzene, okay, can be involved in a Friedal acylation and alkylation reaction. And next here, one more important point, that is acetonylide. This NH, C double bond O, CHC. Even lone pair of electrons are present on the nitrogen. This is also involved in a Friedal acylation and alkylation reaction. Para is the major product. Why? Because this nitrogen, this amide group is a less basic, that do not form the complex with AlCl3. Okay. Why it is less basic? Because of this CO, the electron withdrawing group. This nitrogen, that amides are acting as a less weaker bases. That's why this nitrogen cannot form a Lewis acid base complex with AlCl3. That's why here this compound, nothing but acetonylide, can be involved in a Friedal alkylation as well as acylation reaction. And this ester also can be involved in a Friedal acylation and alkylation reaction. This ester molecule also can be involved. That's it. So here in this case, this alkyl benzene or halobenzene produce a good yield, okay, when compared to phenol also. Okay, that's it. So when compared to chlorobenzene, here toluene gives a more yield, because this toluene is a more reactive. Methyl is a donating group and the halogen is a minus I group. So chlorobenzene is a slightly less reactive when compared to toluene. Of course, here the benzene is also involved in a Friedal alkylation and acylation. Okay, here chlorobenzene gives a lower yield when compared to benzene. When compared to chlorobenzene, benzene gives a more yield, because benzene is more reactive in alkyl substitution reaction. Okay, that's it. But when compared to phenol, chlorobenzene gives a good yield. When compared to benzene, chlorobenzene gives a less yield. Okay, when compared to toluene, toluene gives a more yield. Okay, it is based on the limitation of the Friedal acylation and alkylation reaction. Okay. So here the benzene having electron withdrawing groups are not involved in a Friedal acylation as well as alkylation. Okay, that NH2, even it is a more activating group, it is not involved, because that form a Lewis acid base complex. Okay, very rapidly. Here also we can see the some Lewis acid base complex, because here also lone pair of electrons, but less basic when compared to this NH2. It is less basic. That's why here there is we can see positive reaction but less yield. Okay. So in this case, this chlorine cannot form a Lewis acid base complex with the LCl3. And here we can see good yield of that acylated product. Okay, thank you. Thank you for watching. Please subscribe my channel, like the video and share my video to your friends. Thank you.